Okay, this is homework number 8. Question number 2. In this question, you're gonna have a pin with a pin, roller, 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 and roller. So in this case, you're gonna have 3 degrees of freedom or 5 degrees of freedom. But the way we did in class is 3 freedom. So we just make like 3 freedom. So you're gonna take, because this one's a pin, and this one's a pin.
Could you explain what degree of freedom is?
Degree of freedom is, for example, you have a pin, this pin. You know this is gonna deflect like this. One, two, three. So you're gonna have delta A, delta B, they are equal. Delta C, delta C, delta D, and delta E. In this case, E, you have 1, 2, 3, 4, 5. 5 unknown. So, and you have angle. I think freedom of degree just like the joint that change angle have angles. In this case, you have 1, 2, 3, 4, 5. 5 degree of freedom. But the reason why I said you can take 3 or 5. This is 5. Let me now give you an example for 3. Same thing, same beam. You're gonna have this. But we don't consider this as a angle. We just do this. You're gonna have because this is a far end pin, far end roller pin, and far end roller. So you only have, you don't count this one. So you have no way to draw it. Because this is far end and it's not a fixed point, so you don't consider it as a freedom. So all you have just delta B, delta C, and delta D. So yeah, maybe it's just confusing, but freedom of degree means the delta. See how many delta you have. In this case,
there are 5.
5. But like I said, you can use another way. 3 degrees of freedom. This and this is not fixed, so you ignore it. This, you consider it as fixed point, because they are internal roller or pin. You just, if you have internal roller or pin, you just consider it as a fixed point. So in this case, B, C, D is fixed. So if you want to draw it, not draw it. So let's start with this question. To do this question, the first step is you have to find your K. Dang, this one is not working.
I have the whole box. No, I give it to you.
First, find your K. So you're gonna have K is equal to I over L. In this case, AB is 30, BC is 30, CD is 30, and DE is 30. Everything is 30, so they are equal. So I over 30. Yeah, so everything is the same. This are same. So K volume for all of them are same. So you're gonna put for all members. For all span. So second step, you have to find your fixed end moment. Fixed end moment. So for the first one, fixed end moment, you need to have a fixed end. This one, like what I said before, is not a fixed point. So you don't consider this. Internal roller, it is a fix. So you have fixed end moment B to A, but not A to B, because A is not a fixed point. So you're gonna have fixed end moment BA is equal to FEB, FEM, BA is going to be, where's my table? For this one, you have a fix, you bring it up here, I give you an example. You consider internal moment, internal roller as a fix. So you're going to have something like this. You see this as this. So when you go to your table, because you have a fix and you have a far end pin and roller are the same. So in this case, you're going to use this. From the left side to the right side is negative, but in our case, so this one we're going to have negative, because in this case our fixed wall is right here, and it's B to A, so it's negative. So you're going to have negative something wrong. B to A. B to A. It's negative. Oh, no. I explained small. In the graph, here left to right is negative. So if you have something left to right is positive. In our case, the table left to right is negative, so this case is right to left, so it's positive. So you have positive W L squared over 12 over 8. So you use that equation and you put in your number. W is 2, L is 30 squared over 8. You're going to get 225. And for fixed end moment BC, you're going to have like I said, internal pin or roller you consider as fixed. So in this case, you're going to have something like this. And you have a point load 50. So for this one, this side is only for fix and pin or roller. So you have to look at this side. In our case, the point load is at the center and you have fix and fix. So you're going to have fix and point load at the center. So you're going to use this equation. And BC is from left to right. So it's negative. If you have something from right to left, you have positive. So in our case, it's negative. So you're going to have negative PL over 8, which is P is 50, L is 30 over 8. And you're going to have 187.5. Negative. And for BC, same equation, but this time it's from right to left, so it's positive. So you're going to have F, EM, CB, same equation, same number, but instead of negative, you just have positive. So 187.5. C to D, same thing. Same as B to C, because you have fixed, fixed and fixed, fixed and fixed, and you have 50 adding at the center. Same equation, and it's negative because it's from left to right. CD or CB? CD. BA, BC, CD. BA, BC, CD, yeah. So it is from left to right. What the fuck? B8, BC, negative.
So you forgot CB?
So this one is CB.
CB and
Yeah, it is CB. It's positive. So now you're gonna have
C to D.
C to D. So C to D. C to D. Same as B to C. So it's gonna be negative 187.5. And D to C, opposite. So it's same as C to D, C to B. So you're gonna have C to B. So you're gonna have FEM. D to C is equal to C to B. So same number. And for D to E, do I have DC? Yeah, D to C. So D to E, you have a fix and you have a 4 end pin or molar, 4 end molar. So you're gonna have, yeah, let me just draw this. Fix, and you have this. In that case, we're going to use this one. Fix, and you have a roller, and you have distributed load. So it's from left to right, so it's negative. So for this one, we're going to have negative. DE, you're going to have same formula, but this time it's negative. Same numbers. So you're going to have this, negative 225. So now we have all the fixed end moment. The next one, you have to find the formulas, moment formulas. So let's just isolate them. So formulas, step 3. Moment formula. So first one. The first one, B8. B8 is fixed and the pin. So you're gonna have fixed and pin, fixed and far end pin. So you're gonna have. I mean, there's only 2 equations. The first one is 2 KE times 2 times near. Delta near plus far end minus 3 angle something. Yes. And you have 3 KE. Is that 2? No. It's near delta and no, minus this. This is when you have a fix. No, I'm sorry. This is when you have a fix and a fix. And for this one, is for when you have a fix and a roller or pin. So for the first one, just highlight this. For first one, you have a pin and a fix. So you're gonna have to use this one. So first one, MB8, you're gonna have, because we're gonna use this one, so you're gonna have 3 K, we just find it, which is this. But since K for all the span are same, so you just use K. You don't have to use I over 30, because the number are the same. So you're gonna just put 3K E times 2 near delta. No, is that delta? No, it's not delta. Yo, Mohammed, how you call this?
Theta?
Data. Damn. Data. Near data. So you're near because you're looking for A to B. Oh, I'm sorry. B to A. So B to A. The near delta is delta B. So data B. Why is it keep saying delta? Data B. And the minus this. This is equal to delta over L. But look at this. We didn't have size wave. What is size wave? This is called size wave. When it's wave, delta and delta. But in this case, you have a support, 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 and supports. So you don't have delta. It's not going to move. So in this case, this number is 0. So that's the first one.
So whenever there's a sway, the delta is
Yeah, then you're going to have this. And you have to take the delta divided by the L, the length, which is 30. I mean,
like whatever
just
the
the left, yeah. So for M, we have BA, so we have BC. BC is fixed and fixed. So you're going to have this one, fixed and fixed. So you're going to use this equation. So 2K E 2, you use this equation, no 2. So this one, you use this one. So 2 theta near, so it's going to be, because it's B to C, so the near delta data is delta B plus delta C. Like I said, no delta, so this number is 0. So plus 0, not minus 0. And for MCB, you're going to have 2K E 2 times C to B, so the near one is C. Huh?
That's phi, right?
Which one?
Delta over L?
This?
Yeah.
I don't know how you call this.
Is the angle twist?
Like this.
theta, right?
That's phi. Angle
P,
twist.
okay.
Poseidon sine.
Plus 0, minus 0, so minus 0. So you have C, B, so you have CD. Same equation. Fix, 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 fix. So 2K E 2 C plus D. And we have DC, so you can have DE. D to E is a fix to a roller. So you're gonna have fix and roller. You use this. So you're gonna have D KE delta D, not delta, data minus 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I missed something. DC, oh yeah, I missed the DC. CD, DC, so you what? And DC. So you can have same thing, fixed and fixed. And the last one, MDE, 3KE, delta, no, data. Data D minus 0. See, 1, 2, 3, 4, 5, 6, 6. Okay. Now, after you find this, you have 1, 2, 3, 4, 5, 6. And you have the sum. After this step, first step, K, second step, fixed end moment, Step 3, moment equation. So step 4, sum of the moment equation. So you have to sum up this, and this, because they are fixed points. You have to sum up the force in the fixed points. So for this one, you're going to have BA and BC, and this one, you're going to have CB and CD. And for this one, is DC and DE. So for the first one, you sum up the moment at point B, so you're going to have moment BA plus moment BC. Sum of the moment at point C, you're going to have MCB plus NCD. And the sum of moment point D, so MDC plus MDE. So 1, 2, 3. So now just put in numbers. Let me erase this.
This is slope deflection, right?
So you have equation 1,
Did you write everything down?
2, 3. So now you have to plug in the numbers. So for the first one, you're going to have MBA, which is that. So you're going to have 3. When you put in the equations, when you plug in numbers, you don't have to care about this one if they are the same. In this case, they are the same, so you can just cancel it. Because later or sooner or later, they're going to cancel out, so it doesn't matter. So cancel them out if they are the same. So in this case, 3 times theta B. So you're going to have 3 theta B BA and BC. BA and BC. So you're going to have plus 4 theta B plus 2 theta C and equal to 0. Oh, I forgot to write this. Equal to 0. Oh, crap. Right, let me just erase this a little bit. And you have a plus fixed end moment.
And you erased it.
Fixed end moment. So yeah, it doesn't matter. I have numbers here. So before we find fixed end moment, we have fixed end moment BA, BC, CB, CD, DC, and DE. So just put them back. For BA, plus 225 minus 187.5 minus plus 187.5 minus 187.5 plus 187.5. And this one is negative 225. 1, 2, 3, 4, 5, 6. Okay. What do you mean how much time that?
To finish.
I don't know. You have to draw Sherman diagram.
2 minutes.
Yeah, so you have
ambiguous.
3 theta B plus 225 plus 4 theta B plus 2 theta C minus 187.5 equal to 0. So you solve this, you're going to have 7 theta B plus 2 theta C equal this plus this. You're going to have did I solve that? Okay, you're going to have positive 37.5. Alright. Something wrong. because positive, negative, it's positive 37.5. But when you put it into the equal sign, you have to change it. So become negative. Positive, do it to the zero side, become negative, yeah. So this is the first one. For number 2, you're gonna have CB, CD. So CB, CD. So you're gonna have 4 theta C plus 2 theta B plus 1 87.5 plus CD 4 theta C plus 2 theta D minus 187.5 equal to 0. So just cancel. You're gonna have 8 theta C plus 4 theta plus 2 theta B plus 2 theta D equal to 0. This is the second equation. Number 3 is DC and DE. DC and DE. So you're gonna have 4 theta D plus 2 theta C plus 187.5 plus 3 theta D minus 225 equal to 0. So you're gonna have 7 theta D plus 2 theta C. This plus this become negative. Negative go to the 0 side, become positive. So 37.5. This is equation number 3. Yes, so you're gonna have, let's erase this side now.